Hi, my name is Jason Provol, and I want to be an engineer when I grow up. I go to Marshall Middle School in San Diego, California. Over the course of the past year, I have extensively studied aerodynamic principles such as lift, drag, and gravity. This became the theme of my 8th grade science fair project. The world became so much smaller in 1899 when the Wright brothers built and demonstrated the first flying machine. Uniquely, they designed their airplane by first performing testing in a small-scale wind tunnel. My experiment studied some of the same key principles of airplane wing design that led the Wright brothers to discovering manned flight, and that are applied in the design of commercial aircraft today. In order to study these principles, I had to come up with an innovative way to build a wind tunnel at home and test in our garage. I had to manifold two 20-inch box fans, one at the inlet, one at the outlet. This resulted in airflow velocity inside the wind tunnel measured in the order of 3.44 meters per second. The next problem I had to overcome was to develop methods to measure lift and drag. Again, through trial and error, to measure lift, I developed a technique using springs to suspend the airfoils, and the lift could be correlated to the spring constant. Drag was measured using a horizontal pendulum technique, where the horizontal displacement was measured and then correlated to a calibration system outside the wind tunnel and converted to a Newton measurement. Using these techniques, I was able to successfully quantify the effect of modifications to airfoils on lift and drag, and to correlate the relative results of the dimensionless lift-to-drag ratio. For substantial detail, please read the written report. In the course of testing, I observed an unexpected result. I noticed that when air was allowed to leak outside of the wind tunnel from below the wing and not from above it, the amount of lift observed was substantially greater. Through discussion with one of my important mentors, Mr. Curtis Long from NASA, I concluded that the lift efficiency of a wing might be improved by channeling air from the bottom of the wing, either off to the side of the wing, or even further improved by channeling air from the bottom of the wing to above the wing. I performed supplemental tests to study this effect. In these tests, I drilled holes from the front lower tip of the airfoil, angling back about 135 degrees towards the top. This modification almost doubled the lift of my airfoils. I plan to explore this finding further in the future. This modification offers a potential improvement in airplane wing design. Benefits are listed below. I believe that this finding could lead to a potential improvement in the design of wings, airfoils, car spoilers, and/or other applications of aerodynamics. Thank you for listening, and I hope you'll have the opportunity to further review my report.